Today we're going to cover section 3.1 in our BJU Press Algebra 1 textbook. We're going to be looking at solving literal equations. So let's look at this equation. We have P is equal to 2 parentheses L plus W. And our instructions say solve for the variable L. Now we've got a couple of variables in this equation. We have a P and a W, but they only want us to solve for variable L, which means our answer is not going to be just a number. Our answer is going to be isolating the L and getting it all by itself. So it's very important to identify what we want to isolate. What do we want to get all by itself? We want to get L all by itself. So we have to undo everything that is happening to L in order to get L by itself. So the first thing we would do is we would go ahead and divide everything by 2. And then we would go ahead and subtract the W. And once we have that, we end up with L is equal to P minus 2W divided by 2. And there's two ways you could write this. You could write it as P over 2 minus W. You could also write it P minus 2W over 2. Let's say we have the same equation, but we wanted to solve for W. In this case, we would still divide by 2, but this time we would subtract the L. And so we would get W is equal to P divided by 2 and then minus L. And there's two ways to write that one as well. I did it this way where I did P divided by 2 minus L. But you could also have written it as P minus 2L divided by 2. So a literal equation contains several variables. So again, whenever you're solving for a literal equation, you're not just going to have an answer, a number for your answer. When you're solving for a literal equation, you're picking one variable and you're undoing all of the operations that are happening to that one variable. So it can be solved for one of its variables using all the techniques that we've already learned: multiplication, division, addition, subtraction, distribution, all of those ways that we learned and techniques that we've learned for solving equations, they work for solving literal equations as well. So let's look at example 1. We have the equation F equals W times H divided by L, and we want to solve for H. So we're going to identify our variable. It's H. That's what we're trying to solve for, and we're going to undo the operations. So the first thing we need to do is identify, well, what operations are happening? It looks like we have a multiplication and a division operation that's happening. So the first thing we want to do is we want to undo the division. So we're going to multiply both sides by L, because when we multiply both sides by L, the L will cancel on the right-hand side, which is where the H is, which is what we want because we want H to eventually be by itself. And when we multiply on the left-hand side, we end up with L times F. There's nothing really we can do. We can just write L times F. So now we have LF is equal to WH. We're almost done. Again, we're trying to solve for H. So we're undoing everything that's happening to H. Right now, H is being multiplied by W. So we're going to undo that multiply by W by dividing both sides by W. When we do that, the W cancels out on the right-hand side, leaving us that LF over W is equal to H. And we can, of course, rewrite that to say H is equal to LF over W. Let's take a look at another example. let's say we have P is equal to 2L plus 2W. This is actually the formula for perimeter. We want to solve for L. So the first thing we want to do is we want to undo everything that's happening to L. So we're going to take care of this addition first. So it's plus 2W. So we're going to subtract 2W from both sides. So now we have P minus 2W is equal to 2L. And our last step to isolate the L and get L all by itself is to undo that times 2. So we're going to divide both sides by 2. Now there is a way you can, once you have your L isolated, that's when they might say, well, once you have L, find L when P is equal to 58 and W equals 6. Now this is an evaluating problem. We're going to substitute 58 for P and 6 for W. So we're going to rewrite the problem. Instead of writing P, we're going to write 58. Instead of writing W, we're going to write 6. And then we're going to go ahead and do our order of operations. So 2 times 6 is 12. 58 minus 12 is 46. So now we have 46 divided by 2, which is 23. So the distributive property is so critical whenever we're solving literal equations. It's going to help us be able to manipulate our equations in order to isolate the variable that we're after. Let's look at example 3. Let's say we have ax minus 5b equals 7x plus 18b, and we want to solve for x. So I notice that x is on two sides of the equation, or two different sides of our equation. So my very first thing I want to do is I want to go ahead and move this term here, or I can move either term I want, but I want my x terms to be on the same side of the equation. So I'm going to subtract 7x from both sides, so that way now my x terms are on the same side of my equation. And that means I want to get the term that doesn't have an x on the right-hand side. So this minus 5b, I don't really want it to be on the left-hand side because it doesn't have an x in it. So I'm going to add 5b to both sides to make it cancel. And if I add 5b over here, well, 18b plus 5b is 23b. So now I have ax minus 7x equals 23b. Unfortunately, I cannot combine ax minus 7x because they're not like terms. A is another variable, and I don't know what number a represents. However, I can reverse the distributive property. It's called factoring, where I see that there's an x here and an x here. So I'm going to go ahead and undistribute that x, and I'm left with a minus 7. Because if you think about it, x times a is ax. X times negative 7 is negative 7x. So all I did was I undid the distributive property. I did what was called factoring out, and I undid the distribution property. So now when I want to solve for x, because remember that's our end goal is to solve for x, I'll divide both sides by a minus 7. So now I have x is equal to 23b over a minus 7. So let's go over the steps for solving literal equations. First, using the distributive property, we want to clear all fractions by multiplying by the least common denominator. So you don't want to be working with fractions. We always want to clear the fractions by multiplying by the LCD. Once we have done that, we simplify both sides of the equation. Then we collect all the terms containing the desired variable. So when they say desired variable, they're talking about the variable you are solving for. We want all of the terms that have the variable that we want to solve for on one side of the equation, and all the other terms that we don't want on the other side. Step 4, we're going to use the distributive property or reverse it or factor to isolate the desired variable. Step 5, we divide both sides by the coefficient of the variable. So let's look at an example. Let's solve a plus 2b over c equals cd minus a over b. So step 1, we want to multiply by the least common denominator. Right now I have a denominator of c and b, which means the least common denominator is just going to be cb, or c times b, which means I have to multiply everything on my left-hand side by b and everything on my right-hand side by c. So again, I'm multiplying everything by my least common denominator, which was that b times c. And when I do that, my denominators cancel, which is good. But I do have to distribute this b. So b, it's going to be b parentheses a plus 2b. And then I have this c here that did not cancel, c parentheses cd minus a. So when I distribute, I have b times a, which is ab, b times 2b, which is 2b squared, equals c times cd, which is c squared times d, and then c times negative a, which is minus ac. So now I want to move all of my terms to the correct side. It looks like everything is good to go. I'm solving for, I'm going to go ahead and move the AC to the left-hand side. So I'm going to add AC to both sides. So that means it cancels on the right-hand side, but now I have AC on the left-hand side. And then I want to get rid of this 2b squared on the left-hand side, so I'm going to subtract 2b squared from both sides. So now I have ab plus ac equals c squared d minus 2b squared. So I'm trying to solve for a, and I notice that a is in both of those terms, so I'm going to use my distributive property, and I'm going to kind of undo the distribution of that a. It's called factoring. Because if you think about it, a times b is ab, and a times c is ac. So now that I've done that, if I want to solve for a, I just have to divide both sides by b plus c. All right, the manipulation of literal equations, the reason that we do that is because it's going to be useful in many disciplines. So in science especially, you're going to learn how to manipulate literal equations. When we do geometry, you have to manipulate literal equations. Anytime you're using a formula in an application or everyday life formula, you're going to have to know how to manipulate the equation in order to look at just the variable you're trying to solve for. Sometimes we use subscripted variables. So a subscript is a number that's not above, like an exponent, but below. So for example, this 1 is a subscript on that r. This 2 is a subscript on that r. So these are two different variables. This is variable r sub 1, and this is variable r sub 2. So it's two very different variables, even though they look kind of similar, and they probably have similar meanings, but they're two different. So this might be rate 1 and rate 2. They're both rates, but they're talking about two different rates. So you use a subscript to say this is rate 1 and this is rate 2. They're often used to clarify meaning in formulas, especially in real life formulas. They're treated just like any other variable, as if they were an x or a y. They're still very much the same. They just have a different, it's almost like it's a variable, but it has a different characteristic to it, or a different name to it. So example 5, we have b sub s equals b sub e plus k sub e times m. So every single variable here is different. This is different from this variable, which is different from this one, which is different from this one. There are actually 4 different variables here, so none of them can be combined. So the B sub S represents the boiling point of an ethanol solution, where the B sub E is the boiling point of pure ethanol. So one was the boiling point of a solution, where one was the boiling point of the pure. The K sub E is a constant number that you're usually given, whereas M is called the molality of a solution. So this looks like a chemistry formula. So as you can see, it would be useful to be able to manipulate this equation. Let's say, for example, we want to solve for the boiling point of pure ethanol, then we would have to isolate this variable to one side, which means that we would have to get rid of this by subtracting it from both sides. So that is an example of why solving literal equations is so important. All right, go ahead and try some problems on your own.